This code generates two types of visualizations for a specific mathematical function across a two-dimensional domain, utilizing Python's NumPy and Matplotlib libraries. Initially, the code constructs a mesh grid covering the range from -2 to 2 for both x and y coordinates. Based on this grid, it computes the z values by applying a function that combines cosine and exponential components related to the squared distances from the origin in the xy plane. The first visualization is a 3D surface plot, which vividly illustrates how the z values vary over the xy plane, employing a reversed binary color map to differentiate various heights effectively. Key elements like the title and axis labels are carefully added to improve clarity and comprehension. Following that, the code creates a 2D contour plot using the same dataset, offering an alternative view through contour lines that map the function's topology. This plot provides a different perspective on the function's distribution and the alterations in z values across the specified domain. Together, these plots are instrumental in depicting the function's spatial variations, providing a comprehensive understanding of its behavior in relation to x and y coordinates.